Hello, good day. My name is Smith Adebo, and we'll be dealing with physics today. I'll be taking you physics today, and the topic will be measurement. Measurement. We'll be dealing with measurement for over a week now, and we've gone through measurement of different quantities. I've always hinted on the importance and significance of measurement. I said it helps us to know what we are dealing with. It helps us to know the dimensions of the quantities we are dealing with. So today we'll be talking about measurement of mass. Mass as a quantity. We'll be talking about the measurement. You go to the market, you want to buy meat. You tell the butcher that you want to buy meat, and then you tell him you want 1 kilogram. At times, if you want to buy frozen chicken and the rest, you tell them you want 1 kilogram, 2 kilogram, 1 kilos. Now that kilo signifies kilogram. Now you notice that what the meat is being weighed, it is being measured to give you the right amount you want to buy. If you've bought these fishes, these live fishes, you notice that what you tell them the weight of fish you want, you tell them the mass of fish you want rather. Now the fish is being weighed, and then what happens? You are giving that fish according to the mass of the fish. Now the price of the fish according to the mass. Now those are part of the significance of weighing. At times when we are in the hospital, or when we go to the hospital, we actually test our weight too. We check our weight to know if we are losing weight or our weight is the same due to certain illness. So weight is kind of key in physics and then in other aspects of life too, like I just explained. So today we'll be talking about this measurement of weight, the devices we can use in measuring weight and the rest. Now, in measuring mass, sorry. Now, mass is defined as the quantity of mass or stuff contained in a body. Now, the quantity of mass or stuff that is contained in a body is known as its mass. Now, the mass of a body is measured with a balance. I want you to take note of these salient points because our exams are fast approaching. Now, these are the kind of questions that will probably come out in your WAEC. Now, the mass of a body is measured with a balance. Take note. Now, examples of this balance are beam balance, chemical balance. We also have a lever balance. Now, I go over it again. A mass is defined as the quantity of matter or stuff contained in the body. The quantity of stuff or matter that is contained in the body is referred to as what? Its mass. So if you go to the butcher to buy meat, and then you are telling him 2 kilos. Now that 2 kilo represents 2 kilogram, which is the quantity of matter, the quantity of meat, the quantity of flesh you want to buy. And that's simply the mass. And I made you understand that you can actually use a lever balance, a chemical balance, or a beam balance. Now, measurement of mass. Like I said, it is measured with a beam balance, a chemical balance, or a lever balance. You notice that all of them are purely called balances. Now, the mass of a body is usually measured by comparing it with what? Standard masses. Now, standard masses are already known masses that are known already. Now, to measure the mass of a body, you simply compare it with standard masses. Now, it is by this comparison that you'll be able to ascertain the main mass of the body. Now, to measure with a beam balance, the object is placed on the left-hand scale pan and standard masses are placed on the right-hand scale pan. Now, when a beam balance is being placed, the object will be placed on the left hand, then the standard masses will be placed on the right-hand side. Now, by comparing these two masses, you'll be able to ascertain the mass of the substance you are measuring. Now, okay. So when raised for weighing, the beam of the balance should swing freely about a pivot in the center of the beam. Now, this is simply the mechanisms of measuring the mass of a particular substance. And I said, when raised for weighing, now when you've raised it for weighing, the beam of the balance should be swung freely about a pivot in the center of the beam. Now standard masses are added until the pointer swings equal numbers of divisions on each side of the central mark of the pointer, and it balances on the central mark of the scale. And when this happens, the masses in the top scale pan are equal. I said when you are using what's it called, the balances, or when you are using any balance to measure a mass, you're actually trying to compare it with known masses. And I said known masses are masses that have already been ascertained, masses that are already known. Now these standard masses will be added until the pointer swings equal number of divisions. When equal number of divisions have been swung by the pointer on each side of the central mark of the pointer, now you will observe that what the pointer balances on the central mark of the scale. Now when this balancing occurs, when this happens, the masses in the top scale pan are said to be equal. The mass of the object is then obtained by adding the standard masses on the right scale pan. Now the working operation of the beam balance is based on the principle of moment, and its reading accuracy could be up to 0.001 grams. So the reading accuracy of a what, of a balance, of a beam balance in particular, is 0.001 grams. Now I said after you've compared the mass, after you've compared the mass, after you've added your standard masses until the point must have swung equal number of divisions on each side. Now the next thing you do is to what? The mass of the object is then obtained by you add the standard masses on the right scale pan. Now when you sum up the standard masses on the right scale pan, you get what? The mass of the object you are looking for. Now the working operation is based on the principle of moment. The principle of moment, which deals with balancing of two different weights or two different masses on a particular pivot. And that's the operation with which measuring of mass depends. And I made you understand that the reading accuracy is 0.001 grams. So if you're asking your WAEC, what's the reading accuracy of a beam balance, you should take note that it's 0.001 grams. And then in case you are asked on what principle, because these are probable questions that might be asked in your WAEC, on what principle does the beam balance operate? Now you should take note that the beam balance operates based on the principle of moment. Based on the principle of moment. Now, precautions to be taken when using a beam balance. Like I said, measurement has to do with peculiar or specific instruments for measuring specific quantities. Now, this instrument, which is a beam balance, has its own precautions. There are certain procedures that you must follow. And when you adhere to these procedures, it is very easy for you to get a very accurate value. And by adhering to these precautions, by following these precautions, ideally you have a high chance of getting a very accurate value. You know, values, normally these experiments can never be 100% precise. That's why we have reading accuracies. So we need to follow these precautions in order to get accurate values. So for more accurate results, the following precautions should be observed. You should do the following things to get more accurate results. A, forceps, not bare hands, are used for picking up the standard masses. Now, what are forceps? Forceps are like devices that are used to pick up the objects that you want to weigh or the standard masses that you want to use. Now, the concept of not using bare hands is so that is for you not to contaminate the mass. Now, at times there are some moisture contents on our hand. Like I said, it measures to 0.001 grams, which is considerably very accurate. So now there are some moisture contents on your hand, or there are some dirt that might actually add to the mass of these standard masses. So if you touch it, let's say the value was originally supposed to be 19.001 gram. Now maybe due to the fact that you touched it and then some moisture contact or some dirt from your hand, it might slightly increase to 19.002. And now what we want in any measurement is accuracy. So no matter how small the digit is, or no matter how small the error in measurement is, it is driving us away from the accuracy. That is why it is said that we shouldn't use our bare hands. We should use forceps to pick up standard masses. Now, secondly, objects are wiped dry before being placed on the standard masses. Yes, objects should be wiped dry. Like I said, the moisture content has its own mass. So if the object that is being weighed is not dry, the mass will actually be like the error in measurement will be large, because the object itself has its own mass, and then the moisture content on it has its own mass. So now the mass will now be not just the mass of the object, but the mass of the object plus the mass of the moisture content on it. So that's why we need to wipe it dry to ensure that it is just this object you are measuring. If a cup is wet and you are measuring the cup, the mass of the water, you agree with me that water has its own mass. So the mass of the water will be part of the final result you get. So before you weigh anything, any device, any content, you should make sure that the moisture content is being dried before you place it on the standard masses. More so, hot objects are allowed to cool before weighing. Hot objects are allowed to cool before you weigh them. Now, if you notice, everything I've been saying has always been based on the mass. Now, the heat, excess heat will actually alter the mass of the object. So it should be allowed to cool to its normal temperature before you weigh it. Now, known masses are not added or removed from the scale pan while the beam is in its raised form. If the beam is still in its raised form, if the beam is not settled yet, known masses should not be added on the scale pan. If it is in its raised form now, it is only when the scale pan is in its relaxed form that you can add the known masses to the scale pan. So that's it for the precautions. So today our assignment, this assignment was actually coming from WAEC 2015. You are going to tell me which of the following statements about mass and weight, which of the following statements about mass and weight are correct. A, it says weight is the force of gravity on the body. II says the mass of a body is the quantity of matter of the body. III says the weight of a body is greatest at the equator. And IV says the mass of a body is greatest as the poles. Now, you support your answers with explanations. Yes. Now, if you tell me weight is the force of gravity on a body, if you say this is correct, you tell me why. You support it with notable explanation. So we'll do a brief recap before we go today. Today we talked about mass, and I said mass is the quantity of matter or stuff that is contained in a body. I gave examples of going to the market, you weigh your meat, you tell them you want 6 kilos, you tell them you want 5 kilos. Now the kilos are actually kilograms. You want 6 kilograms of meat, the meat will be weighed before it is given to you. You want to buy your live fish, like the catfish and the rest. Most times you weigh them so you know the particular price apportioned to it. Now, as I said, the mass of a body is measured with a beam balance, a chemical balance, or a lever balance. It is measured with various balances. Now that's the mass of a body. I said I gave you a brief explanation on how measurement of mass works, and I said when raised from weighing, the beam of the balance should swing freely about a pivot in the center of the beam. It should swing freely Now, standard masses are after you've allowed it to swing freely about a particular pivot. A pivot is simply the point of attachment where the beam of the balance are attached. Now, standard masses are added until the pointer swings equal number of divisions on each side. Now, that point where the pointer swings equal number of divisions on the both sides, it is noted that what the masses have coincided, meaning it's in equilibrium. Now when this happens, the masses in the top scale pan are equal. That's what I was trying to say. It means they are in equilibrium when the both pointers on both sides. Now, when standard masses are added on both sides to create a kind of equilibrium, to make sure that these standard masses are what are equal. Hence, we can now use it to weigh an object or determine the mass. And the mass of the object is then obtained by adding the standard masses on the right scale pan. Now, after this has happened and you add your mass on the right scale pan, you can actually determine the mass of the object. Now, this operation is based on what? The principle of moment. And I said you should take note of this point. These are notable questions that could be asked in WAEC. The beam balance operates on the principle of moment. That's 1 point, and its reading accuracy is 0.001 grams. And I said that precautions to be taken when using a beam balance. I said these precautions are important so that we can get accurate values. Now, the main aim and purpose of measurement is defeated if the accuracy is very, very low. So the aim of every physicist or lab attendant is to make sure that his values are very accurate. Now, your values can never be too accurate. So we always want to get an accurate value. Now, the first point here was that forceps and not bare hands should be used for picking up the standard masses. Secondly, and I explained why, I said our hands might have some contents that will actually contaminate the mass. Contaminate the mass in the essence that it might actually increase the mass. Maybe little moisture content, maybe little bacteria on your hand might actually add to the mass. Now, I also said that objects are wiped dry before being placed on the standard masses. That we should ensure that these objects are dry before we place them on the standard masses. Now, I said hot objects are allowed to cool before we should make sure that these objects are not hot, because due to the heat actually affects the mass. Now, until it comes back to room temperature, its normal temperature, you observe that what the mass will be altered. So you wait for it to cool down before you weigh it. Also, I said known masses are not added or removed from the scale pan while the beam is in its raised form. No, the beam should be allowed to relax or should be in its relaxed form before these known masses are added or removed from the scale pan. And I gave an assignment. I said which of the following statements about mass and weight are correct. I said weight is the force of gravity on a body. Secondly, it says the mass of a body is the quantity of matter on the body. III says the weight of a body is greatest at the equator, and IV says the mass of a body is greatest at the poles. So you support your answers with explanations. If I is correct, you tell me. If II is correct, you tell me. If all of them are correct, you tell me. And you tell me why you feel they are correct. Thank you and God bless you. Please ensure you join most of our Zoom classes. Our exams are fast approaching, and then we need to be up and doing. And then if you are watching this video online, please ensure you subscribe to our channel for more videos. Thank you and God bless you.